Hello students, we have been solving the exercise in the chapter functions and exercise 4th of chapter 1. We have been solving question number 16, first sub question of question number 16 we have completed. Now we will start question number 16, second question onwards. Okay, before we start video, please don't forget to subscribe my channel ISC Mathematics. Okay, and enjoy learning at home. Okay, now y is equals to f of x is equal to x minus 1 upon x minus 2. Function f of x is given. We have to prove that f of 1 upon x is equals to f of x upon 3 into f of x minus 1. We have to show that. Okay, so f of x formula is given, that is x minus 1 upon x minus 2. We can find out the value of f of 1 upon x from the given formula. Replace x by 1 upon x. Okay, so on simplifying we will get 1 minus 2x. This is f of 1 upon x. Now let us find out f of x upon 3 into f of x minus 1 equal to f of x is x minus 1 upon x minus 2, 3 into x minus 1 upon x minus 2 minus 1. Let us further simplify, so we will get x minus 1 upon 3x minus 3 minus x plus 2. Okay, which on further simplification will give us 2x minus 1. Okay, now look at these two results, number 1 and number 2. So from 1 and 2 we can say f of 1 upon x is equal to f of x upon 3 into f of x minus 1. Please note down. Okay, now question number 17. In question number 17, function f of x is given by the formula 3x plus 2 upon 3x minus 2. We have to prove that f of x plus 1 upon f of x minus 1 is equal to 3x upon 2. Okay, so let us prove. Okay, take LHS, left hand side. LHS is f of x plus 1 upon f of x minus 1. We will put the value of function f of x. F of x is 3x plus 2 upon 3x minus 2 plus 1 upon 3x plus 2 upon 3x minus 2 minus 1. On further simplifying, we will get 3x plus 2 plus 3x minus 2 upon 3x plus 2 minus 3x plus 2. Okay, minus 2 plus 2 and minus 3x plus 3x will get cancelled. Now 3x plus 3x is 6x upon 2 plus 2 is 4, which on reducing will give us 3x upon 2, and which is equal to RHS. Clear? Please note down. only we have to put the value of f of x in the given formula and simplify. You will get the answer easily. Okay, now question number 18. Question number 18. First one, function f of x is equals to 10x. We have to show that f of x plus y is equal to f of x plus f of y upon 1 minus f of x into f of y. So quite easy questions. Let us take f of x plus y. F of x plus y is equal to, in the formula of f of x, put for x we will put x plus y, so this will become now 10 x plus y. Clear? Okay, now take right hand side, or we can simplify this. Okay, we know that 10x plus 10y is equal to, we have formula 10x plus 10y upon 1 minus 10x into 10y. Now obviously 10x is f of x and 10y can be written as f of y upon 1 minus f of x into f of y. So we will directly get, which is equal to required answer. Okay, so f of x plus y is equal to f of x plus f of y upon 1 minus f of x into f of y. Clear? Second part also let us see. That 2 is quite easy. F of x is equal to, we are given f of x is equal to sine inverse x. We have to prove that sine of f of x plus sine of f of y, we have to show that sine of f of x plus sine of f of y is equals to sine of f of x plus y. Okay, now let us find out sine of f of x plus sine of f of y. Clear? Sine of f of x, what is that? Sine inverse x. So sine of sine inverse x plus similarly here sine of sine inverse y we can write. Okay, now inverse trigonometric functions, we will learn the properties. Sine of sine inverse x is equal to x. Okay, so those properties we are going to use now. Sine of sine inverse x is equal to x, and similarly sine of sine inverse y will be equal to y. Clear? For the values of x ranging between -1 and 1. So okay, now let us find out sine of f of x plus y. See, this is result 1. Now we will find sine of f of x plus y. So sine of, okay, function f of x plus y. So here for x we will put x plus y. So sine inverse x plus y. Again we will use the same property. Sine of sine inverse x is equal to x. So here we are left with x plus y. This is number 2. Here give reason inside the bracket, since sine of sine inverse x is equal to x for all x belongs to -1 to 1. Clear? This property we will learn in the inverse trigonometric functions. So from 1 and 2 we can say that from result 1 and 2 we can write now sine of f of x plus sine of f of y is equal to sine of f of x plus y. Please note down both the questions, both the solutions. Okay, now question number 19. Increasing and decreasing function that we will learn in the chapter which will come later on after differentiation. Okay, increasing and decreasing function. So this question we are leaving. In that chapter we will see this particular question. Now we have next question, question number 20. Okay, question number 20 is like this. Function f of x is equal to sec x plus cos x is given, and function g of x is equal to cos x plus sin x is given. We have to show that f of x is even and g of x is odd. We have to show that f of x is even and g of x is odd. Okay, we know the definition of even and odd function for a function f. If f of minus x is equal to f of x, then the function is even, and if f of minus x is equal to minus of f of x, then the function is odd. So let us check these conditions one by one for both the functions f of x and g of x. First let us take function f of x. Okay, f of x is sec x plus cos x. Now let us find out f of minus x is equal to sec of minus x plus cos of. Now sec of minus x will be equal to sec x. In the fourth quadrant both sec and cos are positive. Similarly cos of minus x is also cos x, and therefore f of minus x is equal to f of x, and therefore f is even. Now let us check g of x. Okay, g of x is given cos x plus sin x. Now we will find out g of minus x. G of minus x is equal to cos x minus x plus sin minus x equal to, now cos x and sin both in the fourth quadrant will be negative. So cos x of minus x will be minus cos x. Similarly sin of minus x will be minus sin x. Taking minus sin common we get cos x plus sin x. Okay, and therefore g of minus x is equal to, we got minus of g of x, and therefore g is an odd function. Please note down. Okay, now let us solve the next question. In question number 21, we have to find the domain of the given functions. No problem, we will find out. Okay, question number 21, we have to find the domain. Okay, number 1, say function f of x is given to be square root of 1 upon square root of 1 minus x into x minus 2. Okay, now function f, we know that function f is defined only if this value is greater than 0, not equal to 0, because in the denominator if there is 0 then function will be undefined. Okay, so f is defined if 1 minus x into x minus 2 is greater than 0 or x minus 1 into x minus 2 is less than 0. So we have two critical points. Okay, here critical points are x is equals to 1 and x is equals to 2. So by method of intervals, by method of intervals, 1 is less than x is less than 2, and therefore the domain is in open bracket or open interval 1 comma 2. Please note down. Okay, now next question. Second of question number 21. Say function f of x is given as sine inverse of log x square by 2 to the base 2. Okay, function is given. Let us take this, consider this value to be z. Let z is equal to log of x square by 2 to the base 2, and therefore we have function f of x is equal to sine inverse z, where z lies between -1 and 1, including -1 and 1. Okay, and therefore -1 is less than z is less than 1, therefore -1 is less than log x square by 2 to the base 2 is less than or equal to 1. Okay, now -1 and 1 also can be written in the log format as log 2 to the base 2, 2 raised to -1 to the base 2. Okay, less than or equal to log x square by 2 upon 2, and here we can write 1 as log 2 raised to 1 to the base 2. Clear? Because this on simplification will give -1 and this on simplification will give 1. Now let us remove log throughout. So we will get, therefore 2 raised to -1 is equal to x square by 2 is less than or equal to 2, or 1 by 2 is less than or equal to x square by 2 is less than or equal to 2. Now we have to find the value of x. Okay, so let us remove this 2 in the denominator, so multiplying by 2, and therefore 1 is less than or equal to x square is less than or equal to 4, and therefore 1 is less than or equal to modulus of x is less than or equal to 2. Clear? If you take the square root, then square root of x square is modulus of x, and therefore the domain is -2 to -1 union 1 to 2. This is the required domain. Please note down. Okay, now let us solve third question of question 21. Question 3. Okay, question 3 is log 2 plus x upon 2 minus x to the base e. Okay, now we know that log function is defined. Okay, let f of x is equals to log 2 plus x upon 2 minus x to the base e. Now f of x or function f is defined for log x is defined for all x greater than 0, and therefore this function is defined for 2 plus x upon 2 minus x greater than 0, or x plus 2 and x minus 2 less than 0. Inequality will be changed. 2 minus x we have written as x minus 2. Okay, now critical points. Here the critical points are x is equals to 2 and x is equals to minus 2, and therefore by method of intervals we have to see the negative sign. Okay, so x lies between minus 2 and 2, and therefore minus 2 is less than x is less than 2, and therefore domain of function f of x is minus 2 to, please note down quickly. Okay, now question number 22. Let us solve question number 22. Question number 22. Function f of x is given to be 4 minus x minus 7 raised to 3 raised to 1 by 5. We have to find the inverse function f inverse x. Let us find out. Okay, we have a method. Let y is equal to f of x. We will use this method, and therefore y is equal to 4 minus x minus 7 raised to 3 whole raised to 1 by 5. Okay, on simplifying, we will get y raised to 5 is equal to 4 minus x minus 3 whole raised to 3. On further simplifying, we will get x minus 7 raised to 3 is equal to 4 minus y raised to y. Now remove 3 from here, so we will get x minus 7 is equal to 4 minus minus y raised to 5 whole raised to 1 by 3. Finally, in order to make x the subject, we will remove this 7, that is transpose. Therefore, x is equal to 7 plus 4 minus whole raised to 3. Finally, replacing x by f inverse y. Therefore, f inverse y is equal to 7 into 4 minus y raised to 5, or now this y we can write as x, and therefore, or replacing y by x, we will get f inverse x is equal to 7 into 4 minus x raised to 5 whole raised to 1 upon 3. This is the required f inverse x. I hope you have understood this question. Now question number 23. Okay, we have to show that the following functions are bounded and we have to find the upper and lower bounds. Given functions are bounded and we have to find the upper and lower bounds. Okay, now let us, before solving this question, let us see what are bounded functions. Let us try to understand the term bounded functions. Okay, so let f be a function which is defined in its domain. Okay, now if there be two numbers small a and small b in the domain of f, if possible, we have two numbers a and b in the domain of function f, okay, such that f of a is less than or equal to f of x is less than or equal to f of b, for all x belongs to domain, clear, then f of x is called the bounded function and f of a and f of b are respectively called lower bounds and upper bounds. Clear? So if you have two numbers or two values of x in the domain for a given function f of x, such that f of x lies between f of a and f of b, then we will say that f of a and f of b represent the lower and the upper bounds. Please note down this. Okay, now let us try to understand this fact with the help of one example. Suppose we are given a function f of x is equal to 2x plus 1 and the value of x lies between here 1 is less than or equal to x less than or equal to 2. So we will find out f of 1 is equals to 2 into 1 plus 1. Okay, so 2 1 the 2 plus 1 3 and f of 2 will be equal to 2 into 2 plus 1 is equal to 5, and therefore we can write f of s is less than or equal to f of 1 is less than or equal to f of x is less than or equal to f of 2. Clear? Okay, and therefore f of 1 is 3 is less than or equal to f of x is less than or equal to f of 2, and therefore 3 and f of 2 is 5. So therefore 3 and 5 are respectively upper and lower bounds. Clear? So how to find the upper and the lower bounds? You will be given the formula of a function and the values of a and b will also be given. So find out f of a, f of b. Okay, that will be respectively lower and upper bound. Okay, now let us solve the questions on the basis of this. Okay, question number 23, number 1. F of x is equal to x square plus 2x minus 3 for 1 less than or equal to 4 less than or equal to 4 is given. Obviously, function f is bounded both lower and upper. Okay, because we have lower limit of x and upper limit of x is also given. Lower limit is 1 and upper limit is 4. So f is bounded function. Okay, we can write. Okay, now let us find out f of 1, or directly we will write that this is lower bound. Lower bound will be f of 1, which is equal to 1 plus 2 minus 3 equal to 0, and upper bound is equal to f of 4 is equals to 16 plus 4 minus 3 16 plus 4 2s are 8, so 24 minus 3 21. Okay, and therefore we have lower and upper bound. Lower bound is 0 while upper bound is 21. Similarly, we have second question. Second question is similar quadratic expression. You can try yourself. Third one, f of x is equal to sin x or minus pi by 2 less than or equal to x less than or equal to pi by 2. Okay, obviously this function is also bounded both lower and upper because we have both lower boundaries and upper boundaries. Okay, and let us find out the lower boundary and lower bound and upper bound. So f is bounded function. Okay, now here we will calculate the lower bound. So its lower bound will be f of minus pi by 2, which is equal to sine of minus pi by 2 is equal to minus 1, and upper bound is equal to f of pi by 2 is equal to sine pi by 2 is equal to 1. Okay, so lower bound is minus 1 and upper bound is 1. Similarly, in the next question you are given f of x is equals to 10x, or the given limits both lower and upper boundaries are given. Clear? And therefore you can calculate upper and lower bound. Okay, now we will solve question number 24. Okay, let us solve. We are given f of x e raised to ax plus b, and we have to prove that f of l into f of n into f of m is equal to f of l plus m plus n into e raised to 2b. Okay, formula of function f of x is given to be e raised to ax plus b. Let us take LHS left hand side, f of l into f of n into f of m is equal to, now in order to find f of l in the given formula for x we will substitute l. So e raised to al plus b, similarly f of n will be e raised to an plus b, and f of m will be e raised to am plus b. Now let us simplify. Since the base e is common, we can add the powers. Therefore e raised to al plus an plus am plus b plus d plus b, we can write 3b. Now this can be simplified as a raised to al. Okay, do one thing, from these three terms take a common. So in a common, inside bracket l plus n plus m. Okay, again 3b we will split into b plus 2b. Okay, now this will become obviously f of l plus m plus n. So for this we will substitute is equal to f of l plus m plus n, or one more step we can write. Let us simplify one more step. E raised to a into l plus n plus m plus b into e raised to 2b. Yes or no? We have split here, and now this is f of l plus m plus n into e raised to 2b, which is equal to RHS. Please note down. Okay, now next question number 25. question number 25. Function f of x is given to be b into x minus a upon b minus a plus a into x minus b upon a minus b. We have to prove that f of a plus f of b is equal to f of a plus b. Okay, let us take left hand side. LHS is given to be f of a plus f of b. Now you know finding f of a. In the formula of f of x, for x we will substitute a. So this will become b into a minus a upon b minus a plus a into a minus b upon a minus b, plus similarly for f of b, x will be substituted by b. So b into b minus a upon b minus a plus a into b minus b upon b minus b. Now b into a minus a is 0 and 0 upon b minus a will be 0 plus a into a minus b upon a minus b will be equal to 1 plus b into b minus a upon b minus a is 1 plus a into 0. So these two terms will be 0 and we are left with a plus b. This is the value of f of a plus f of b, which is equal to f of a plus b. How? Now let us see. Since f of a plus b is equal to, now in order to find f of a plus b, x will be substituted by a plus b. So we will write b into a plus b minus a upon b minus a plus a into a plus b minus b upon a minus b. Plus b minus b and plus a minus a will get cancelled. So f of a plus b is equals to b into b square upon b minus a plus a into a square. Okay, we can do one thing. Here a minus b is there. If you take minus sign common, so here this sign will change to minus and next term will be a square upon b minus a. Now b minus a will be LCM and numerator we have b square minus a square. Applying difference of square formula, we will get b minus a b plus a, and b minus a will get cancelled. So we are left with b plus a upon 1 or a plus b. Clear? So this is equal to RHS. Please note down. Okay, now let us solve question number 26. Question number 26. We are given f of x equal to ax square plus bx plus c. We are also given the values of f of 1, f of 2 and f of 3. We have to find the values of a and b. Also we have to find f of minus 1. After finding the value of variables a, b and c, we will calculate f of minus 1. So our first task is to find the values of a, b and c. Okay, function f of x is given by the formula ax square plus bx plus c. F of 1 is 6. Okay, now you know how to find f of 1. In the given expression, in place of x we will put 1, and therefore we will get the equation a plus b plus c is equal to 6. Number this as equation 1. Okay, again f of 2 is given to be 11. So if you put 2 here, so we have 4a plus 2b plus 1 is equal to 11. Say this is equation number 2, and similarly f of 3 is 18, therefore 9a plus 3b plus 1 is equal to 18. Okay, now obviously in order to find the values of a, b, c, we have to solve the equations 1, 2 and 3. Let us first solve 1 and 2. Solving equation 1 and 2, we have 4a plus 2b plus 1 is equal to 11, and a plus b plus c. Actually here it is c. Okay, so a plus b plus c is equal to 6. Okay, now let us reduce. So we will change the sign, plus c minus c will get cancelled. 4a minus a will be 3a plus b is equal to 11 minus 6 will be 5. Number this equation as equation number 4. Now let us solve 1 and 3. You can solve any of 2 and 3 or 1 and 3. So we will solve 1 and 3. So we have equation number 3, 9a plus 3b plus c is equals to 18, and a plus b plus c is equal to 6. On changing the sign and subtracting, we get 8a plus 2b is equals to 12. Okay, or 4a plus b is equal to 6. And finally we will solve equation 4 and 5 to get the values of a and b. And the values of a and b we can put in the equation number 1 to get the value of c. Please make a quick note. If you know Cramer's method of solving the system of 3 equations, linear equations, you can use that. Okay, that method we will see in the chapter named determinants. Okay. Okay, now I am removing the left hand side and solving equations 4 and 5. Okay, so we have 3a plus b is equal to 5, and 4a plus b is equal to 6. On solving we get minus a is equal to minus 1, implies a is equal to 1. Okay, substituting a is equal to 1 in equation 4. Therefore 3a plus b is equal to 5. This is equation 4. Let us put a is equal to 1. So 3 into 1 plus b is equal to 5, or we will get b is equal to 5 minus 3, and therefore b is equal to 2. Okay, now values of a and b we will substitute in equation 1. A plus b plus c is equal to 6. So that we will get the value of c. Okay, so I will remove this now, right hand side. Okay, now substituting values of A and B in equation 1. What was the equation 1? A plus B plus C is equal to 6. Okay. A is 1, B is 2 and C we have to 1 and therefore C is equal to 3. Okay, and therefore the values of A, B and C are 1, 2 and 3 respectively. Now it is quite easy to find the value of f of minus 1. So let us first find out f of x. We will substitute the values in the formula for ABC respectively. Substitute 1, 2 and 3. So we will get x square plus 2x plus 3. Now we have to find f of minus 1. So 1 minus 2 plus 3 is equals to 2 and therefore f of minus 1 will be equal to, please make a note. Okay, now next question, that is question number 27. I hope you have understood this one. Question number 26. Now let us solve question number 27. Okay, we are given f of x by the formula 3x square minus 6x plus 4. Okay, we have to find, it is given that for what value of x is 3 into f of x equal to f of 3x. So we have to find the value of x which satisfies the given equation. Okay, so what is the given equation? Let us write down 3 into f of x is equals to f of 3x. Simply put the values. 3 into f of x is 3x square minus 6x plus 4 equal to, in order to find f of 3x, we will substitute x by 3x. So 3 into 3x the whole square minus 6 into 3x plus 4. Okay, so here 3 3s are 9x square minus 18x plus 12 is equal to 9 3s are 27x square minus 6 3s are 18x plus 4. Let us simplify. So we will get 18x square. Okay, 18x and 18x will get cancelled on both the sides. Okay, so let us reduce this. And 4 minus 12 will be 8. Is it clear? Okay. So now let us simplify. So 2 can be taken common. So we have 9x square minus 4 is equal to 0. Therefore 3x the whole square minus 2 the whole square is equal to 0. Therefore 3x minus 2 into 3x plus 2 and therefore 2 values of x we will get 2 by 3 and x is equals to minus 2 by, please note down. Okay, now next question, question number 29. Okay, question number 29, it is given that f of x is equal to a minus x raised to n whole raised to 1 upon n for a greater than 0. It is given that a is positive and n is also a is a positive real number while n is a positive integer. N is positive integer. Okay, we have to show that f of x is equal to x. Okay, now let us find out. This is simple. F of x is given to be a minus x raised to n whole raised to 1 by n. So f of x is equal to f of a minus x raised to n raised to 1 by n. Again, in the formula of f, in place of x we will put this whole value. Okay, so it will become like this. A minus, for x we are going to put this bracket, a minus x raised to n, a minus x raised to n raised to 1 by n, and the power of x is n, and the whole power is 1 by n. Let us simplify. This n will get cancelled. So we will get a, open this bracket, signs will be changed. So a minus a plus x raised to n raised to 1 by n. Okay, this will also get cancelled. Plus a minus a. So we are left with x raised to n raised to 1 by n. So finally we will get x, and therefore f of x is equal to x. Please write down. Okay, now let us solve next question. Question number 30. Function f of x is given to be e raised to x plus a, and g of x is also given, that is equal to x raised to b square, and we are given h of x, the third function, which is e raised to b square x. We have to prove that g of f of x upon h of x is equal to e raised to ab square. Okay, let us prove. Let us take LHS, left hand side. LHS is g of f of x upon h of x. G of, what is function f of x? E raised to x plus a upon h of x is given to be e raised to b square x. Okay, now in order to find g of e raised to x plus a in the formula of function g, x will be substituted by this bracket. So e raised to x plus a and x raised to b square is there. Okay, upon e raised to b square x. Now let us apply power of power law. We will multiply the powers. So on simplification we can write e raised to b square x plus ab square upon e raised to b square x. Let us split this above term into two terms. So e raised to b square x into e raised to ab square upon e raised to b square x we can write. Clear? And therefore this e raised to b square x will get cancelled. We are left with e raised to ab square, which is equal to right hand side. Please note down first. Okay, now we will solve the next question. Question number 31, 32. 2 into f of x minus 1 minus f of 1 minus x upon x is equal to x. We have to find the formula of f of x. Okay. There are two parts in the question. This is the first part. Okay, this is the first part. We are given the formula 2 into f of x minus 1 minus f of 1 minus upon x is equal to x. Give this equation number 1. Now let us substitute x by 1 upon x. So now in equation 1, x will be substituted by 1 by x. So we will get 2 into f of 1 by x minus 1 minus f into, this will become 1 minus 1 by x upon 1 by x is equal to 1 upon x. On further simplification, 2 into f of 1 by x upon x minus, we will get f of x minus 1. Clear? This is equation number 2. Now we will solve the two equations, solving equations 1 and 2. Okay, so we will multiply first equation by 2 so that both the terms will be equal with opposite signs, so we can reduce. Okay, so we will multiply equation 1 by 2 and write down. So 2 2 is 4 into f of x minus 1 minus 2 into f of 1 minus x upon x is equal to 2x, and the other equation is 2 into f of 1 minus x upon x minus f of x minus 1 is equals to 1 upon x. Okay, let us add the two equations. So this like terms with opposite signs will get cancelled. 4 minus 1, we have 3 into f of x minus 1 is equals to 2x plus 1 upon x, and therefore x minus 1 is equal to 1 by 3 into 2x plus 1 upon x. Say this is equation number 3. Okay, now if you want to find f of x, obviously here x can be substituted by x plus 1, so plus 1 minus 1 will get cancelled and you will get x. Okay, so substituting x by x plus 1 in equation number 3, you note down the remaining steps I will do on the left hand side. question is not having two parts, only one part. F of x and yes. So this is question number 32. Okay, now I will remove this. Okay, now let us substitute x by x plus 1 in equation 3. Once again I will write down here equation 3, f of x minus 1 is equal to 1 by 3 into 2x plus 1 upon x. Okay, let us substitute x by x plus 1. So here we will get x plus 1 minus 1, 2 into x plus 1 plus 1 upon x plus 1. On simplification we will get the value of f of x to be 1 by 3 into 2 into x plus 1 plus 1 upon x plus 1. This is the final answer. Okay, now let us solve the next question. Question number 33. Okay, this question contains two parts. Number 1, f of x is given by the formula 4 raised to x upon 4 raised to x plus 2. We have to prove that f of x plus f of 1 minus x is equal to 1. Okay, let us prove the first part first. Take left hand side, LHS is equal to f of x plus f of 1 minus x is equal to 1. Therefore f of x we have formula right as it is. Okay, in order to find f of 1 minus x we will substitute x by 1 minus x. So 4 raised to 1 minus x upon 4 raised to 1 minus x plus 2. Okay, let us simplify. This we have to prove equal to 1. So 4 raised to x upon 4 raised to x plus 2 plus 4 upon 4 raised to x, 4 upon 4 raised to x plus 2. On further simplification we will get, first term we are not going to touch. Okay, this will be written as 4 upon 4 plus 2 into 4 raised to x. So from the denominator taking 2 common, we will get 4 raised to x upon 4 raised to x plus 2 plus, if you take 2 common from here, so 2 to the 4, so we are left with 2 upon 4 raised to x plus 2. Now if you take LCM, you will get 4 raised to x plus 2 upon 4 raised to x plus 2, which is equal to 1 and which is equal to right hand side. Okay, please note down first. After you complete this, we will see the second part in the same question. This is part 1. Clear? do is like this. We have to show that f of 1 upon 1997 plus f of 2 upon 1997 plus f of 3 upon 1997 plus up to f of 1996 upon 1997 is equals to 998. Okay, now since we know that see, we have result f of x is equal to, or we have this result that f of x plus f of 1 minus x is equal to 1. This we have already proved, okay, in the first case. Now if you put x is equal to 1 upon 1997, then f of 1 minus x will be equal to 1996 upon 1997, and we know that f of x plus f of 1 minus x will be equal to 1. Yes or no? Implies f of 1997 plus f of 1 upon 1997 plus f of 1996 upon 1997 will be equal to 1. Okay, similarly first plus last will be equal to 1. Similarly second from the beginning and second from the last. Okay, sum of both these terms, f of 2 upon 1997 plus f of 1995 upon 1997 will also be 1. Okay, so similarly f of 2 upon 1997 plus f of 1995 upon 1997 will be equal to 1, and so on if we go. Okay, so there are how many terms? Total 19, starting from 1 2, we have last term is 1996. Okay, so if you take 2 then therefore total number of terms will be half. Okay, and therefore 1 plus 1 plus 1 plus up to the last term will be 1996 by 2. Okay, is equal to times. Okay, so 1 plus 1 plus 1 plus 998 times is equals to, we will get 990. Clear? Write down. I hope you have understood. Since the sum of first and last term, second and second last term, third and third last term, taking in this way, okay, the total number we are taking 2 terms at a time. Sum of 2 terms is 1. So total we will have such 998 times 1. 1 plus 1 plus 1, 998 times, and that will be equal to 998 1. Clear? This is 9998 times. Okay, now the last question of this exercise. Question number 34. F of x is equals to cos of log x. We have to find the value of f of x into f of y minus 1 by 2 into f of x minus y plus f of xy. This question was asked in IIT 1993. Okay, formula function f of x is given cos of log x. Okay, let us find out f of x into f of y. Okay, so that will be equal to cos of log x into cos of log y. Okay, and 1 by 2 into f of x minus y plus f of xy will be equal to 1 by 2 into f of x minus y, that is cos of log x by y, okay, plus cos of log xy. Now let us simplify this term. So 1 by 2 into cos of, okay, log x minus y is equal to obviously log x minus log y. Yes or no? Okay, and plus here cos of log xy is equal to, we can write cos of log x plus log y. Yes. Okay, you write down this one. The further steps we will do in the next step. Okay, let us go through the steps once again. We have to prove that f of x into f of y minus 1 by 2 into f of x upon y plus f of xy is equal to, okay, we have to find the value. Function f of x is given by the formula cos of log x. Separately we are finding the two values. First we have calculated f of x into f of y. So that is very simple. F of x is given only cos of log x, and for finding f of y, x will be replaced by y. Then we have taken the second term and written f of x upon y, replace x by x upon y, and in order to calculate f of xy, replace x by xy. Then we have used the properties of log. Log a by b is equals to log a minus log b, and log ab is equals to log a plus log b. Now let us further simplify. Remember the value of f of x, f of y is cos of log x into cos of log y. Okay, now this term we will further simplify. Here use CD formula, cos c plus cos d. What is the formula? 2 cos c plus d by 2 into cos c minus d by 2. So let us put the formula. So 1 by 2 into 2 cos c plus d. If you add the two terms, 2 log x by 2, so we will get log x only. Yes or no? Okay. And cos c minus d, if you subtract, then minus log y minus log y. Okay, 2, we will get minus 2 log y, because log x and minus log x will get cancelled. Here minus log y will come. So minus log y minus 2 log y. So let us write down what minus 2 log y by 2. So 2 will get cancelled, will get only log y. why? Because cos of minus x is equal to minus cos x only. We know this property in the fourth quadrant. Cos is always positive. Cos of minus theta is equal to minus cos theta, positive only. So we got the simplified value. Okay, now let us put again the question. F of x into f of y minus half into f of x minus y plus f of xy is equal to f of x into f of y was cos of log x into cos of log y minus this, the value of this is also the same only, cos of log x into cos of log y. So similar terms with opposite sign will get cancelled and the value will be 0. I hope you have understood all the questions in this exercise, fourth exercise. Okay, with this all the exercises of the chapter functions are over. Now the next topic will be binary operations. Okay, so in the next video we will see binary operations. Thank you very much.